Hi! So in this video I will be talking about the newest mechanical engineering innovations happening in Alberta and affecting Alberta in 2016. For the past 3.5 years, a team of undergraduate students from the faculties of Science and Engineering at the University of Alberta have been developing the very first Alberta-made satellite, known as Experimental Albertan No. 1 Satellite, or X-ALTA-1. The X-ALTA-1 left campus in August to travel to the Netherlands to join 49 other CUBE satellites for final testing. X-ALTA-1 will make a pit stop aboard the International Space Station, where astronauts will prep the satellites for their final launch into the thermosphere. It is expected to journey for roughly 18 months and, in its first year, travel the world 5,000 times. During their journey, the satellites will send measurements from multiple points in the thermosphere back to researchers on Earth for anywhere between 9 months and 18 months before they burn up in the atmosphere. A CubeSat is a miniaturized satellite for space research, usually in units of approximately 10 by 10 by 10 centimeters, that offers all standard functions of a large satellite. So the advantages of using the CubeSat platform are that it's actually faster to develop and cheaper to develop and launch than a larger satellite. This is because a CubeSat will have a maximum mass of 1.3 kilograms, and they often use off-the-shelf commercial components for their electrical and structural design, making them more cost-effective. The Alberta SAT team, with guidance from Dr. Ian Mann of the Physics Department and Dr. Carlos Slung of the Mechanical Engineering Department, is also designing and building a miniaturized digital fluxgate magnetometer. This magnetometer will be used for high-precision measurements of how solar winds interact with the Earth's magnetic field and monitoring space weather. This magnetometer and the CubeSat will be working together to collect data from the thermosphere. When you combine a large number of CubeSats with the same sensors into a network, as with the QB50 mission, looming scientific questions can be investigated using the unique multi-point nature of the data collection allowed by the CubeSat network. This has not been achieved in the past, and it is said that the QB50 mission will make space history through the launch of a network of 50 CubeSats developed by universities from all across the globe. One of the main objectives of the QB50 project is to carry out atmospheric research within the lower thermosphere, between 200 and 380 kilometers at altitude, which is the least explored layer of the atmosphere. So, why are we so interested in this? Well, the thermosphere is a layer of Earth's atmosphere above the stratosphere and the mesosphere, between 95 and 700 kilometers above the surface of the Earth. It is filled with atoms and molecules that absorb large amounts of solar radiation. Space weather events such as solar flares, geomagnetic storms, and other forms of electromagnetic radiation can cause a spike in the density of electrons in the thermosphere. According to many scientists and researchers, these fluctuations in the density of electrons in the thermosphere can interfere with satellite signals and even change the trajectory of a satellite in orbit. Because we don't yet understand how the density of Earth's thermosphere changes the trajectory of a satellite in orbit, in the event a connection is lost with a satellite during one of these solar flares, there is a danger of serious satellite collisions that could put even the International Space Station at risk. Each satellite is equipped with one of 3 different sensors that will be dispersed throughout the Earth's lower thermosphere to measure how it is affected by space weather events. So by having 50 satellites taking measurements around the Earth at the same time, researchers will be able to develop a better understanding of what the thermosphere actually looks like and how it is being affected. The development of the first ever satellite designed and built by AlbertaSat could represent the beginning of a thriving aerospace industry in Alberta.